Okay, so another quick review, and this is multiplying radicals. So when adding radicals, it's like adding like terms. Now when multiplying, be careful. It's coefficient times coefficient, right? AB, and then radicand times radicand, xy, right? And the indexes have to match, all right? The indexes are going to have to match if you're going to be able to multiply radicals. All right, so in the most simplistic form, so when you see something like this, all right, I already know the negative 7 is times the 4 for a negative 28. But I don't want to do the rest of the multiplication right now. All right, so that's a negative 28, but now I got to look at my radicands. I just don't want to multiply them because I want to simplify before I multiply. So I have a cube root. I'm looking for 3 of any given factor. Well, I see this 20 is a 4 times 5. Okay, so again, I usually don't go this far, but just to be clear, look at that. There's 3 3s. I'm getting a 2 out. So this negative 28 is going to be times a 2. What about my variables here? Look at my x's. I have 2 here and 2 here. So let's split this one up into x times x. Now I can take the 3 x's and take the cube root and get an x out. Look at my y's. 1 y there and 2 more there. For 3 of them, cube root of y cubed is y. So I want to take everything out I can. All right, everything else is left in. What do I have? A cube root. And what is left inside? Just a 5x. Clean it up. So negative 56 xy times the cube root of 5x. Okay? That's the idea. That's how we're dealing with these. Okay, so how about one other problem? And I'm a little bit over into the weeds on this, and so I'm a little bit in the way there, but that's okay. We'll make it work. So what would you do with something like this? Okay, so we have a monomial times a binomial, and that binomial has an exponent. So we got to deal with exponents first, right? Let's deal with the exponents first. Okay, so again, this is really a 2 times the square root of 5 minus a 3 times the square root of negative 2. And also, before I do anything else, remember the square root, any even root of a negative radicand is an I. So I'm going to make that the square root of 2 and take the I out. And again here, square root of 2 and take the I out. Okay, so now let's go ahead and multiply. We got to distribute. 2 times the square root of 5 times 2 times the square root of 5. 2 times 2 is 4. Square root of 5 times square root of 5 is a 5. 4 times 5 is 20. That first term is a 20. Second term, the outers. A positive 2 times a negative 3i is a negative 6i, and a square root of 5 times the square root of 2 is a square root of 10. So I have negative 6i times the square root of 10. All right, let's now do this inner times the inner. Negative 3i times a 2 is again a negative 6i. Square root of 2 times 5, square root of 10. And let's do now the outers. All right, negative 3i times negative 3i is a positive 9i squared times square root of 2. Square root of 2 is 2. So positive 18i squared. Now, all of this is still multiplied. So let's clean up, see where we're at. Negative 6, negative 3 times the square root of 6. Okay. Don't forget, the I squareds are in negative 1. So this is a negative 18. So 18 negatives and 20 positives leaves me 2 positives minus 12i times the square root of 10. And now we got to finish the last distribution. Okay. Negative 3 times the square root of 6 times 2 is a negative 6 times the square root of 6. But watch what happens here on the back. So let me see if I can use some color. Negative 3 times a negative 12i is a positive 36i. But on my radicands, I'm looking already, I'm thinking a 6 is a 2 times 3, and a 10 is a 2 times 5. And see how I can get a 2 out? So I get out a 2, and what's left? Square root of 15. Clean it up. Negative 6 times the square root of 6 plus 72i times the square root of 15. And if you want to be a purist and you want your I in the back, then you're going to put your I there. I don't like that format because it looks like it's in the radicand. But that's the answer, and that's what you need to do even on something that looks that difficult.